welcome back to this channel. In this video, we're still under the topic carboxylic acid and its derivative. However, in this video, we only focus on acidity. Before we go in details, let's look at this table. Basically, this table allow us to compare the acidity among the homologous series of alcohol, phenol, and carboxylic acid. So basically, as we know, acid able to react with active metal, base, and also carbonate compound. So from here we can see that alcohol only can react with active metal, while carboxylic acid can react with all the active metal, base, and also carbonate. But for the phenol only react with active metal and base. So if based on this table, we will able to know that the carboxylic acid is the most acidic among these three, while the alcohol is the least acidic among these three. So later we will look at the explanation why carboxylic acid is the most stable among these three. Okay, let's start with the factor of resonance effect. So in general, we know if there is an acid with the presence of water, it will produce the bond between O and H will break down, and this H will combine with this H2O to form H3O plus. So this compound structure RCOO negative, we will know it as carboxylate ion. Okay, is means the carboxyl group with the oxygen, carboxylate ion. So this carboxylate ion from here we say that resonance is stabilized. So means that the resonance effect make this ion become stable. Okay, so if becomes stable, so means that the compound is not favorable to shift to the left. Okay, not favorable shift to the left. If the compound or the ion not favorable to shift to the left, so that means the concentration H3O plus is high because we are always keeping in the right hand side. So when concentration H3O plus is higher, so means that the acidity also higher. So what's the meaning of resonance effect? So when we want to explain but related with the resonance effect, the keyword here we are using is either is the electron or the negative charge. In the carboxylate ion are delocalized. Delocalized means they will moving in between. Okay, that means they will not at a fixed position. Like here, there is one oxygen over here. So and then there is another oxygen at the bottom here. So the negative charge of the ion, if you look at here, there is a negative charge. So this negative charge, they will moving in between these two electronegative oxygen. Okay, so now we already agreed that for the carboxylate ion, there are resonance effect at where the electron delocalize between two electronegative oxygen atom. So if you still remember in the chapter of phenol, we also mentioned that the negative charge or the electron at the oxygen also delocalize over the benzene ring. But in the benzene ring, there is carbon atom. So the difference between these two compounds now is the delocalization between two oxygen atoms, and then for the phenol side, the delocalization happen in between the carbon atom. So this main difference make them have different acidity. So how we going to explain this phenomena? Based on the sentence here, they say that because oxygen is more electronegative, okay, therefore the resonance effect will be more stable compared to the phenol ion. So the other one is the alcohol. Okay, this one is the alcohol, and then the general name for this alcohol we will know it as alkoxide because this is the alkyl group. Okay, means the alkyl group combined with the oxygen, we will know it as alkoxide. It's less stable because of there is no resonance effect. Besides from that, the alkyl group also act as the electron donating group. Okay, if you still remember in the chapter of phenol, we already discussed that electron donating group will lower the acidity. However, in here we will discuss the electron donating group and electron withdrawing group EWG in the next slide. So both EDG and EWG, their effect generally we know it as inductive effect. There is another factor that we can consider when we explaining the acidity between the molecules. Okay, in this slide, we will do a summary about how the factors can affect the acidity. Based on the previous slide, we already have the idea that resonance effect will increase the acidity. Electron donating group decrease the acidity. And then later, we are going to look at the effect of EWG, which will increase the acidity. So basically, if you already know this factor how they affect the acidity, at the same time you also know that this factor how they affect the basicity, which we will going to learn in next topic, which is chapter 18. Okay, so when we discuss about the EWG, so the very common EWG that used in our question is the halogen group. Okay, this is one of the EWG. Okay, not the only one. This halogen is one of the example of EWG. Okay, so if the EWG is nearer to the carboxyl group or the alkoxyl group or the phenol ion, so that means the acidity will going to increase. Okay, acidity is going to increase. Another factor is, so for example, for this one, if I have CH3, C double bond O, OH, so the halogen, for example, if I have Cl over here and another compound, the Cl is here. So between these two, this one is more acidic, okay, because the position of the Cl is nearer to the carboxyl group. Okay, the other factor is the more EWG, the higher the acidity. So look at this example as well. If we have propanoic acid, both propanoic acid consists of the halogen, and then another one only have one halogen. So in between these two, definitely the more EWG will increase the acidity. So the last one is the higher the position of the halogen in EWG, of the halogen which is the EWG in the periodic table. So let's say now we have another example. One is bonded to bromine and then the other one is bonded to the Cl. So Cl is at the higher position if compared to bromine. So this one is more acidic. Okay, this is the summary about how the factors affect the acidity. Okay, now here let's explain how the EWG can increase the basicity. So based on this statement here, halogen is an example of the EWG at where it will decrease the electron density. So because of the EWG seems like withdraw the electron from this carbon, so means that there will be electron density is decreasing. So when the electron density is decreasing, will cause the bond OH here become weaker. So once the bond OH is weaker, so this bond easy to break down. So once the bond is break down, they will lose a proton. So which means it will produce the H plus. So will cause the concentration H plus increase, at where we understand that if the concentration H plus increase, the acidity will be increased as well. One example in the notes, okay, here we need to compare the acidity between the 2-fluoropropanoic acid and 2-fluoropropanoic acid. So based on this question, I think it's very obvious that the difference is chloro and fluoro. So explain your structure. So based on here, first we need to draw the structure. Second, we need to identify the uh, effect basically. So in this question, both are halogen, so we know that they are the EWG. But these two halogen are different, so means that we need to compare the strength of the EWG, and then lastly we will discuss the stability of the carboxylic ion. Okay, so at the right hand side here we already draw the structure, and then now we also already identify the EWG. So fluorine and chlorine, they have different position in the periodic table. So just now we mentioned that the higher the position, the stronger the electron negativity will be higher, and cause the fluorine is more withdraw the electron more compared to the chlorine, and it will stabilize the carboxylic ion more, and therefore 2-fluoropropanoic acid is more acidic. Okay, another condition is sometimes the question may give us the pKa value. As this one, we need to relate a bit with what we learned in semester 1. When pKa value increase, means that the Ka value will be decreased. When Ka value decrease, as we know, the acidity is decreased. Because of the dissociation of concentration, H plus is lower, cause the pH value higher. So again, once the pH value is higher, means that the acidity is lower. So if we look at here, 2.86, the pKa value is the lowest. So means that this one is the most acidic. So when we look at these three carboxylic acid, carboxylic A, B, C, all these three have the chlorine as the EWG. Okay, what makes them different is the position. Okay, and then we notice that we know that the nearer the halogen, the EWG, to the carboxyl group, acidity increase. So and then it is very obvious, this Cl is the nearest to the carboxyl group, so the pKa value is the smallest, which indicate it is the most acidic. Okay, let's proceed to the tutorial question. Arrange the following in order of increasing acidity, and then we need to do the explanation. So phenol, hexanol, benzoic acid, three different homologous series. So alcohol, phenol, and also benzoic acid. Okay, benzoic acid is the most acidic because the conjugate base resonance is stabilized by the resonance. Okay, due to the delocalization of electron between two oxygen atoms. Okay, this is like what we mentioned. The keyword here basically we want to see the resonance is stabilized, and then delocalization of electron between two oxygen atoms. While the other one is the phenolside ion. Okay, we also can use the term negative charge at the oxygen delocalized onto the carbon in the benzene ring. So due to the oxygen is more electronegative than carbon, so the carboxylic ion is more stable and cause the benzoic acid more acidic than the phenol. Okay, so while for the other one, alcohol, you can mention that the alcohol side is the least stable because there is no resonance stabilization. So this make them have different acidity. So next question, we will look at question number B. So at here we notice that the question B, they have EDG for the methyl. Okay, and then chloro and fluoro both are EWG. And then propanol acid doesn't have EDG, also doesn't have EWG, also doesn't have the resonance effect. Okay, as we know, this is EDG, and EDG will decrease the acidity, so that's why this is the first when we do the arrangement. While propanol acid has no EDG and EWG, so we consider like in the middle. Chloro and fluoro is EWG, so EWG increase the acidity. But the difference between these two is the position, means that the electronegativity. Okay, so now let's look at how we're going to do the explanation. So 2-fluoro as propanol acid is the most acidic because it has the strongest inductive effect. Okay, so here we will mention both fluorine and chlorine are EWG, which will weaken the OH bond. However, fluorine is noticed more electronegative than chlorine. Therefore, the bond is much more weaker and easy to release H+. 2-methylpropanoic acid is the least acidic because there is methyl group, and this methyl group will act as the electron donating group, make the bond become stronger, and H+ is difficult to release. So that's why the acidity is the lowest. Okay, so we already finished the acidity. So in next video, we are going to discuss the preparation of carboxylic acid. Thank you. Bye-bye.